Dear students, in this video, we will see about the lightning controls and areas of the controls and lightning energy audit. So coming to the first slide, the buildings in this pie chart. This is the information of the United States and United States energy consumption. So in this, 39% is for buildings and 28% is for transportation and 33% is for industry. So coming to the buildings, that further classified into again two types. What are the two types? Residential and commercial. Residential and commercial. So in residential, highest or most cases we consume the energy for lighting is 12%. 12% energy we can consume for lights in the residential purposes, and in the similar fashion for the commercial purposes, highest energy will be consumed by the lights only. So as a total, this is the 28% and this is the 12%. Nearly 42% of the 39% of the buildings will be consumed for the only lighting only. So that means if you control the energy wastage in lights or lighting systems, then we can conserve the energy. So this is the main criteria here. So this graph helps us to answer that. It shows the how we use energy in the country, and you can see the buildings use the most energy and lights in commercial buildings uses the most energy. So the what are the various area controls for the lighting controls is, first one is the allow occupants to control unneeded lighting. So what are the requirements for this control is at least one manual lighting control for each space enclosed by ceiling height partitions, so readily accessible to the occupants and located in the space with some exemptions, and must provide on and off functionalities and manually operated. And what are the lighting control solutions are dimmers and multi-scene controllers. So here our expectation is up to 0.2 watts per square feet lighting for security or egress, and areas where only authorized personnel are allowed to use the controls. And second one, that is the B, allow the occupants to moderate light levels to save energy. So what are the requirements? Required for the spaces 100 feet square or larger that have a connected lighting load greater than 0.5 watts per feet square, and each luminary must be controlled by one of the following methods. So those following methods are nothing but manual dimming and lumen maintenance and tuning and automatic daylight controls and demand responsive lighting controls, etc. And the control solutions are dimmers and multi-scene controls. So areas with only one luminary and not more than two lamps, classrooms with lighting load of 0.7 feet squares and less need only one control step between the 30 to 70% are of full lighting power. And third third control, eliminate after hours lighting waste. So what are the requirements? Automating lighting shut off controls for all lighting on every floor, and override of automatic shut off allowed for not more than the 2 hours, and separate controllers for the spaces not exceeding the 5000 feet squares. And control solutions are time switch and occupant sensors, etc. And the expectations for this is the lighting for the 24 hours operation and lighting in the corridors and guest rooms and dwelling units and parking garages, etc. And the spaces that require the occupancy sensors are office spaces up to 250 feet square and multi-purpose rooms less than the 1000 feet squares, and classrooms and conferences or meeting rooms and hotels or guest rooms. And lighting in these spaces must be automatically reduced by at least 50% when unoccupied. Stairwells and corridors and warehouse aisles and open areas and library bookstore aisles all are. And other control zone is saving lighting energy in daylight spaces. So what are the requirements? Automatic daylight controls are required in primary and secondary sidelight daylight areas and skylight daylight areas. So what are the control solutions means? Daylight sensors and dimmer ballasts. So space uses less than the 0.3 width per feet square, and rooms where the total lighting power in the daylight zones is less than the 120 watts. These are the expectations. And another control zone for reducing the lighting energy conservation for for achieving the lightning energy conservation is reduced peak electricity demand. So what are the various requirements means demand responsive automatic lightning controls that can uniformly reduce lightning power by minimum of 15% below the total installed lightning power upon the receipt of a demand response signal. And the control solutions are building level processors and full dimming control. So these are the necessity of the lightning control and various control techniques to provide the or to control the lightning energy wastages. And coming to the lightning energy audit, the lightning energy audit can be explained with mainly 4 points or 4 steps. So under that, the first step is assess the existing conditions. Assess the existing conditions. So to conduct a lightning audit, we will first need the basic lightning information such as the number of lights and their location and their time in use to help you understand the current energy use attributed to lightning in the facility. So this information will help us to understand how much we are currently spending and the potential savings available from the lightning efficiencies. So existing conditions assessments worksheet. So for each lightning location, obtain the answers to the questions below. Not every topic will be relevant to the every location. So these are the main lines for assess the what are the various lightning saving chances. So what are the various existing conditions are location of the lights and type of fixture and type of lamp in the fixture and watts for fixture and number of lamps per ballast and desired light level, fixture mounting height and hours per week the fixture is in operation and presence of the reflectance in the room and structural obstructions and safety and security measures required and presence of the automatic timers and number of fixtures and spacing between the fixtures and number of lamps per fixture and types of ballast and watts per ballast, fixture condition, availability of the daylight and weeks per year the fixture is in use and layout and dimensions of the room and maintenance schedule and typical and likely atypical conditions and electrical cost per kilowatt hours. So these are the various assessment worksheet. From these worksheets, not every topic will be relevant to the every location. And step 2, assess the opportunities for increasing the lightning energy. So first, what are the chances and assess the opportunities. So determine if the following opportunities exist for a given location. Tons of lights in unoccupied areas and determine if existing lighting levels are higher than the recommended levels and review outside the lighting needs and install more efficient ballasts and remove unneeded lamps and install more efficient lighting and employ more effective lighting settings and follow a regular maintenance schedule and use daylight effectively. Use daylight effectively. These are the opportunities for increasing the lighting energy conservation. So calculate the savings. So for each change, use the following formulas to calculate the annual savings. So dash watts into dash hours per day into dash days per year divided by 1000 watts per kilowatt hour is equal to we get 1 kilowatt dash kilowatt hours. So that this much of kilowatt hours into cost per kilowatt hour per year is equal to total annual kilowatt hour charges saved by this channel. So in this manner. And step 4, implementation and monitoring of the expected energy saving proposal. So after deciding the savings, so definitely we have to implement, and if there is any side effects are there, so we can monitor and rectify those in order to accept the energy saving proposal. Thank you.